Hi everyone, today in Integrated Math 2 we're going to go over Chapter 6, Lesson 2. Here are the objectives. Make sure you write them down in your notes. Alright, so let's go over the difference between congruent and non-congruent. So as you see here in the non-congruent box, all these are shapes and they are the same shape and they are the same size. They look a little different, but if we were to actually cut them out and place them on top of each other, they would match up perfectly. However, if we look over here, and if we were to do the same thing, if we were to cut them out, each one of these, and we try to place them together on top of each other, they would not line up because they are not the same. They're not the same size, and they are not the same shape even. So, definition of congruent polygons. Two polygons are congruent if and only if their corresponding parts are congruent. So as you can see, A is congruent to H, B is congruent to J, K is congruent to C. Notice the colors also match up with them, so it's just more of a visual way so you can also see this happening. But remember, if we have angles that are congruent, that means we also have sides that are congruent to each other. So we have side AB, which is congruent to side HJ. Then we have side BC, which is congruent to JK. Then we have side AC, which would be congruent to side HK. And because all of these are congruent to each other, we can say that these two triangles are congruent to each other. And more specifically in our case, triangle ABC is congruent to HJK. Notice how these still match up. So reds are first, blues are second, and then greens are third. Just keep that in mind. So even when you are saying that these triangles are congruent, it's important to have the lettering correct in the correct order as well. Then we have the third angle theorem. If two angles of one triangle are congruent to two angles of the second triangle, then the third angles of the triangles are congruent. So in this case, we have if angle C and angle K are congruent, and angle B is congruent with angle J, then we know that the last two angles, angle A and L, are also congruent to each other. So we have the reflective property of triangle congruence. We have if we have triangle ABC, it is congruent to itself, triangle ABC. Symmetric property of triangle congruence. If triangle ABC is congruent to EFG, then we know that triangle EFG is congruent to triangle ABC. Notice all that happened was they flopped sides and from where they were. Alright, then we have the transitive property of triangle congruence. If triangle ABC is congruent to triangle EFG, and triangle EFG is congruent to triangle JKL, then we know that triangle ABC is congruent to triangle JKL. Notice what happens here is, just like we mentioned before, is that middleman disappears. And then we are left with the two outer triangles here. Alright, so now let's go over example 2. We want to show that the polygons are congruent by identifying all congruent corresponding parts, then writing a congruent statement. So we have this angle here, QPR, is congruent with angle MPN. Alright, so now let's go to the second arcs here. So we have two here and we have two here. So this one we could just say angle R because there's no confusion on this. So angle R is congruent with angle N. And then we have another angle here. We have Q and M. Notice they both have 3 little marks here. And these other ones had 2, and this one had 1. So this is how I'm identifying that they match. Then we have angle M, which is congruent with angle Q. And then once again, we can say that our sides are congruent. So we have side QR is congruent with side MN. Then we look at the 2 marks on each of these. So MP is congruent with QP. Then I have one more side that is congruent. So NP is congruent with RP. But then they want us to make a congruent statement. Well, we have proven that everything in this triangle is congruent to everything in this triangle. So the last thing we have to say is which triangles are congruent to each other. So I have that triangle PMN is congruent with triangle. Well, P started with 1, so I'm going to say P again. M started with 3, so I'm going to go to Q. N had 2, so I'm going to go to R. So I know that triangle PMN is congruent to triangle PQR. And there we go.